Alright, problem number 2. Given the vector u is negative 2I plus 3j, and v is 4I minus j, algebraically find the component form of the vector w, which is 2u minus v. Well, first off, remember that when we're given vectors in this form, u is the same here as saying negative 2 comma 3, like that. And v is the same as saying 4 comma negative 1. The I is giving you your horizontal component, and the j is giving you your vertical component of these vectors. So then, we want to find w, which is 2u minus v. Well, we know that u is actually negative 2I plus 3j, and minus, we know v is actually 4I minus j. So let's distribute and see what we get. 2 times negative 2 is negative 4I, plus 2 times 3 is 6j, minus 4I. Distribute that negative into that negative j to get plus j right there. Combine like terms to get w equals negative 4I minus another 4I gives us a negative 8I. And then a 6j plus a j gives us a positive 7j for vector w right there. We want to write this in component form, so we're going to say that vector w equals the vector negative 8 comma 7, and that is our answer. Now we want to sketch the resultant vector w as composed by 2u and v. And I give you a little hint here. I say, remember, subtracting a number is the same as adding the opposite of that number. So I think when we are showing these vectors drawn, for showing w, I think it's going to be a little easier for us to picture this as 2u plus a negative v. So let's just figure out what negative v is real quick. Let's say negative v is going to equal negative times vector v, which is 4I minus j. Well, we did this a moment ago. We are going to get negative v equals negative 4I plus j. So now we can sketch all this. So I'm going to draw some axes right there. And I'm now going to first start by putting my my starting point on the origin right there. Now I want to add 2u. Well, I know u is the vector negative 2 comma 3. So I'm going to give myself 1, 2 tick marks for my negative 2x component. And then, what did I say? Positive 3. So I'm going to give myself 1, 2, 3 going up. I'm going to write my terminal point right there. I'm going to draw that vector in, and that was a u. But remember, I'm going to u, so let's go 1, 2 to the right again, and up another 1, 2, 3. Now we have a second point. There is our second u. So now we have 2u, and we're adding to it a negative v, and we found negative v to be negative 4I plus j. So another negative 4 in the x direction. So 1, 2, 3, 4 again. And now our vertical component is j. So we're going up 1 from there. So I'm going to dot that point in over here. Ooh, that was pretty inaccurate. How about more like that right there? Looks a little better. And now we're going tip to tail, so we end up right there. And then our resultant is going to be the line that goes from the starting point at the origin straight to that ending point, all the way up there. And we get that pink resultant right there, which is w, which is 2u, 2 times our vector u, plus, or, well, let's just say minus, no, let's say what we said before, plus A minus V. And then that shows you each of those pieces. There's your minus V, and then there's our U and our U, and then there's our vector W right there. And that's a pretty good looking diagram. If you look at that point right there, we should be at the coordinates we found earlier, -8 and +7. And if you count those tick marks, we are. So that's what I'm looking for with your algebra, and that's what I'm looking for with your diagram.